Okay, this section I will introduce you guys how to just run for the t-test for two population at the same time and compare the mean of the population based on the hypothesis testing of the t-statistic. Now let's do it, and I will practice this with the software test sample. If you want to do it, you can go and download for the data file chapter 10. Actually, it's not chapter 9 but chapter 10, but however they quite the same, so we can just utilize them for this example. We open it on, and the software test is the data about the current and the new. Even when we're not really clear about what will be exactly the syntax or the business context of the data set, but we can make some kinds of like short assumption about we compare the mean of the population of current and new software, okay, something like that, okay. So because up here we just have the two sample, okay. Alright, so this the 12 data point over here for the current values, and the new values, they will be actually just two sample, and we want to make sure that if there can any difference between the mean values of the current and the mean value of the news, okay, how we can do it. I show you how we gonna run it on the data analysis bottom. You open on the data and then data analysis. Alright, now you can move it on and down into the t-test. You can get the two sample assuming unequal variance, okay, and you click OK. Now the first variable ran, we go to select this one. The second variable ran, this could be this, okay. At the same time, the hypothesized mean difference will be 0. That means we want to compare the mean of the population of the first sample and the mean of population of the second sample. If that's similar, that means the difference will be 0, or they will be different, that means the difference will be different to 0. Label for the first round to just make it sure that the computer will understand the first round of the data will be not the data. Output ran, we click it on, and over here we save it. You say OK. Right, now you can clearly see that this could be the result, and they have already measured for some kinds of the mean of the sample for both the current and the new sample. We also had the name of the variant and of the current and the new, and we want to make sure that what will be the result. Over here I would just recommend you guys to stick on the p-value to tell of the number like this, okay. So because the p-values of the t-test from two sample is 0.033 and is smaller than 0.05, so that means we can reject the non-hypothesis. And non-hypothesis here, this would be two population mean are similar, okay. But actually now it should be we accept the alternative hypothesis, that's a two population mean are different or are significantly different. Right. Okay, now Let's try to demonstrate the thing on SPSS and how we can run for the pairs of the two population like that run on SPSS, right? We first of all go and import for the data into SPSS like the same way that I already demonstrated for you in the previous video. So we go into your local computer working directory and then figure out where you save for the data. Over here I open it on and change for the type the data of the data would be Excel, right? And I use for the same data sets as I already demonstrated for you in the previous step, software test.SPSS. This could be how it could be imported into, and I click OK. Okay, I have the two data, current data and the new data, right? And the variable view also show me two variables like this. Each of them have about 12 observation. Okay, now let's go and try for the t-test for a pair of them. I'm going to analyze bottom and then use for compare mean. I go to pair sample t-test. I want to make sure that two variables will be put in the right place. So current for the first variable, new for the second variable. You can of course change for some kinds of option like confidence interval percentage, could be 95% or 90% or 99%. But with me over here, I would just use with the default 95%. And that will be everything. You click OK. And the result could be automatically created. Over here, you can see that could be the pair and the number. So the mean of the current software would be like 325, when the mean of the new software will be, the cost will be just 286. So look like the mean of the sample only, they are different a little bit, right? But however, to just compare the mean of the current and the new in terms of the mean of population, we go and check for the different chain. Okay, that should be 39 something, and I test it for the t-test, and the significant level that's jump into 0.032. So I can conclude that with the data that's going to be happening, I would say look like this could be significantly different in the current and the new of the mean of them. Okay, however, I'm pretty sure that you guys will normally don't work with the kinds of data like this, but it should be more popular when you go and download for the data or collect the data in the same file like this. So for example, with this one, right, I had the gender and I had the height. So the height would be different when I collect for all the data of the female and male and female and male. So they have up to like 210 observation over here. Okay, I clean the data also. Of course, in some way, I can try to just do it manually by just create for the two step, by I short them, or I can just filter them, right? For gender, I will select not all of them, but just man. Okay, and I have all the data of the man only. Alright, and I will create a new file. This could be male. This is the height of male. Okay. At the same time, I can do it with the female height. Okay, and I can collect for the data like this. Go up here and gender. We select just female. Alright, and I can collect at the same time and create for another bottom. Alright, so I have two columns with the female look like more than the male. female about 132 observation, while the male about 70 something. And of course I can run at the same time like I already created with the t-test, right? Assuming for unequal variance. But however, I would not waste my time to do that. When I say that, I can really run it on my trick. So how can we do it? One more time I open it on SPSS, and for in terms of the hypothesis testing, SPSS is much more superior compared to the traditional methods and approach on the data analysis of the Excel. So I prefer to just demonstrate for you guys to do it. In this case, run everything on SPSS. I go and select for the data set that I already have it, open it on, and import them into the SPSS. You see over here, right? All the thing has been created. Gender and height. And gender has been automatically assumed to be a string data, while height that should be numeric. Now let's go and do for the t-test. Let's compare the mean. But however, now we select for independent sample t-test. The window will be pop up, and we select for the height will be the test variable, because we want to make sure that there is any kind like question could be any different in the mean of the male height and the mean of the female height, right? And I select for grouping data. Remember about gender, we have the two unit values including for male and female. Okay, so the first group I define it to be male. Just make sure that they will be the same and matching with the what you already put in, right? The second group will be female. Okay, and you click continue. Option will be just the same, so I don't have any kind of modification, and that will be it. I click OK, and the result will come out very quick, and you see there will be 77 male and 132 female, with the mean of their haze, right? The haze of mean in the male group will be about 173 centimeter, while with female that's a little bit lower, 158 centimeter. Now let's come into very important part. For the t-test like this, we have the two stage. First of all, we have to check this will be the live-in test for the equalities of the variance. We have to make sure that if that will be non-hypothesis for the variance of the height will be equal in the both sample of the male and female, or they will be not equal. Okay, and let's check it when we see for the F statistic and the significant level. Over here, because that was the significant level of the F test is larger than 0.05, right? The significant level of 0.05 or 5%. So that means we fail to reject for the non-hypothesis, and we have to say the variance of the two sample now that will be equal, and by that way we will just use for the first round to read for the result. Now we not use for the second round, but the first round only we already determine, make up by ourselves. And we go into the second stage, the t-test for the equalities of the mean. Just very simple. We see the t statistic, degree of freedom or something like that, but however we just have to check for the significant level, and because there's a significant level for two-tail or the two-way is 0.000, that means it's smaller than the significant level of 0.05 or 5%. That means over here it is significantly to conclude that the mean of the male and the mean of the female in haze, they are different, and the mean difference is around like 14.25 something centimeter, something like that. We can say male, they are higher than female, and they are different in the mean of the population in the average. Thank you so much for your understanding.